Καλώς ήρθατε μας. Θα μας πει ο Μάρκος για έννοηση της pipeline. Τον καλωσορίσουμε. Ακούτε καλά. Όλοι οι οποίοι πίσω και θα πούμε, ωραία. Καταρχήν, για να καταλάβω, υπάρχει κάποιος εδώ που δεν μιλάει ελληνικά. Is someone here who doesn't speak Greek?
One gentleman there.
Should we that's good. We need this. As we suggested. And I'm guessing everyone speaks English. All guys. Λοιπόν, να σας ξεκινήσω. Βασικά θα μιλήσω για ένα release pipeline, συγκεκριμένα γιατί μιλάω αγγλικά. So I'm gonna give a talk about an iOS release pipeline that was built in using Jenkins and set up using Jenkins, and a lot of scripts and a lot of ideas around it. So that is actually a real world example. Okay, generally speaking, it was 5 years ago. Okay, so a lot of things have changed obviously since then. The tools have changed. My memory is not that good. So at the time, to give you a bit of a context, I was the first hire for a bank in the UK to protect some people around it. I'm not going to say the name of the bank. I was the first hire, as I said, as an iOS developer. So when I walked into this bank, there was nothing really in terms of automation or not even an existing team doing iOS development. So I was the first guy to come in. So whatever I'll tell you today is what I've managed to build from scratch and from what it was available. So my memory may not be that good, but if you have any questions at the end of the presentation, I'm sure I'll remember a lot of things as I'm going through this. So you have to remember this is the enterprise. How many of you work at an enterprise environment? Raise your hands. Okay, so about half of you work in an enterprise. So for those of you who don't know, we're talking about multiple teams, multiple departments, multiple stakeholders in an organization. So there's a lot of moving parts. And obviously this increases complexity by a lot. Because it's no longer just your team with one developer being you and another sitting next to you, working your way through code, fixing conflicts through your merges just by talking to each other. You're talking about a big organization, you're talking about teams that are distributed. So they're not necessarily in the same office. You talk about teams that specialize in quality assurance testing. So not only your team is involved in delivering this app, there's also dedicated teams like QA teams that are focused in delivering this app and making sure of the quality of the app. And there's multiple stakeholders. So how many of you have worked in a team of, let's say, more than 4 people? Okay, about half of you as well. So what I mean by multiple stakeholders is you're no longer just a team of developers and maybe a manager. Maybe you have someone who is a business analyst somewhere in this organization that defines requirements, business requirements, for you to build. Maybe there is, as I said, someone from a QA team who's responsible for end-to-end testing. Because obviously we're talking about apps that are not siloed. These are not apps that are standalone. They require a server. They require an environment potentially, which is different. And speaking about environments, there is this idea of multiple environments where basically an environment, you can think of it as a server. So how many of you have worked with multiple servers or multiple environments in your work where you have to think which server you are talking to each time? Okay. So an environment, again, you can think of it as a simple server that your app talks. So you have potentially a client-server architecture, and those environments, ideally, they are the same. They are the same in terms of the data that they hold. They're the same in terms of any configuration like certificates that they have. But obviously that's not always easy. So for example, especially in a bank, you have things like customer data that you need to protect. So you can no longer, while writing the app, necessarily talk to a product environment that has real customer data. Because then this is a security risk. So we're talking about multiple environments here. The other thing is, because of the nature of the team, the size, being remote, the scale of the team, this solution was working and was based around featured branches. How many of you know featured branches? Okay, so most of you know what featured branches are. Very simple in one sentence. It's basically when you don't develop directly to master branch. You base your work on a branch, and then as soon as you're done, you merge to master. That's a featured branch. And typically, they would map per user story. How many of you know what a user story is? Okay, so most of you are familiar. The other thing is, so each individual developer would work on a feature branch, and then you wouldn't merge to master. So even though you work on a feature branch, you wouldn't necessarily merge to master, you would merge into something called a development branch. And a development branch is simply, you can think of it as a staging, as a way to promote features that then you make a decision whether or not they will go live. And I will explain a bit more. I'm just giving you an overview right now. And then finally, you release on master. So you merge to master, and then you tag your release, you tag your code, you bundle your app, and you push it to your clients. So first I'm going to give you an overview of how it looked, because there's a lot of things to go through, and I will try to break it down bit by bit, but I'm pretty sure by the end of this talk your mind will explode, because there is so much complexity, there is so many things to talk. So I'll try to go slow. So as I said, first we have feature branches. So this is a feature branch, the blue one. This is our development branch. And your code typically as a developer would sit over here. So you would do one commit of your work, and then you would merge to development. Okay? So at the end of that, potentially you've worked on a single user story, maybe even a new feature. Maybe it's one-on-one. And you would merge to development. Now at that point, this is where the release pipeline actually kicked in. So it wasn't monitoring feature branches. It started from the development branch going forward. So at this point, as soon as you merge development, Jenkins would trigger a build, very simply. It would just trigger a build. And through this build, it would create a test summary. So basically, how many tests have you run? Or how many tests have run, because Jenkins runs the tests. What's your test coverage across your code base? Obviously, build your code, see if it compiles. And the main thing to notice here is that this is done for two reasons. One is to monitor quality, and the other thing is to have a feedback loop. And what is a feedback loop? And what is it about the feedback loop? And why does it need to be short? So a feedback loop is basically getting feedback from your CI whether the build is broken, for example. And obviously, you want to know this as early as possible. Why? Because the later you know whether the build is broken, the much further you are from the actual code that broke the build. Okay? So, you want the feedback loop to be as short as possible. The minute you make a change, you need to get feedback that something is broken. Think of it like when you're writing code in Excel. As soon as you have a typo, or as soon as you don't reference a variable, you get this thing called, you hit build, or Excel automatically compiles your code and it notifies you and tells you you broke this, so you know how to change it. So this is no different. This is again a different kind of feedback loop, only it's managed by your build server. And you want it to be short. The other thing, obviously, is to monitor quality at this point. So, have we had any test regressions? Are you all familiar with what a test regression is? Okay, so a test regression is basically this. You write your code, you compile it. How do you make sure that it works? You run it in the simulator, right? Or you run it on a device. You have to see it with your eyes, probably. Especially if it's a feature that it has a UI. Yes, you may be using Interface Builder, but we want to see the real thing. So, one way to do it is to write a test. It could be a UI test, it could be a unit test, and that way you know that that test protects your code from failing. Now, if your test runs today and it passes, that's all good, it means your code works. But down the line, the test might fail. And why will it fail? Well, you know, it happens possibly on a Friday night when you want to go home and you quickly to commit this code and you forget to run the test, or it takes too long to run those tests, and all of a sudden, without you realizing, you broke some tests. So this is about monitoring quality. This is making sure tests are not failing that used to pass. So that's what regression is. And this is all for now. So every time you merge, you build, you make sure your code compiles, your tests run, everything looks good. And a day typically goes like this, 9 to 5. You work on feature branches, you commit, you merge development, build tells you whether it has passed or regressed, you move on. You move on, you move on. And over time, obviously, you're hitting a peak, you're making progress. You're doing all this work into development. Now, there's something else that happens. And this doesn't depend on your work, and it doesn't depend on an action that you took, which is to merge development. This is based on time. So this one says, for the release pipeline that every night there's going to be an over-the-air download. How many of you are familiar with over-the-air downloads for iOS apps? Not a text file, no. So, what is an over-the-air download? Basically, taking it further and not only building the app, not only running tests against your code, but also actually producing an IPA. You may be familiar with that, the IPA, which is the final product that you will install on a phone, whether for test flight or from the App Store. But in this case, it's only used during development. And in this case, we put it on the server, and we make it available. And this, as I said, happens during the night. And there is one thing here that obviously you have to consider. The thing about this pipeline that I'm describing right now is that it's more than simply a Jenkins job that automates a lot of the processes. It actually requires you personally and your team and everyone involved in this team to know what the process is. What does that mean? I'll tell you a simple example. Never break the bill. How many times have you come to the office on a Monday morning only to find that the bill is broken, your code is broken, and then you go through the logs and you see an ask from it saying a quick fix on Friday evening at 9 p.m. because for whatever reason, the manager pushed, there was a deadline, there was whatever. So this pipeline that I'm describing does not work unless you are committed to the process. And as I said, the process here dictates that at the end of the day, because remember previously we said 9 to 5 will work, we commit, Jenkins gives us feedback, we react to it, we fix the build. So then come midnight, between 1 and 3, everything is fine, everything is green. Jenkins will build this IPA for us as an over-the-air download. And that not only saves time, because that means Jenkins doesn't have to do again and build and again run the test. But also it means that you know how the process works and you are invested. Because let's say that Jenkins did run at 1 a.m. in the morning, and it broke the build, and it broke the test. Who's going to fix it? You'll be at home sleeping, right? So it's a two-way street almost, because if you go too far into the pipeline and automate everything, then you will have a pipeline that dictates, that tells you how to do your job. And then you're no longer doing a human's work, you're doing what you're told. So you're not in control of it. And that's not a good place to be. You want to tell Jenkins and the machines and all these tools that you have what to do for you, rather than the other way around. So, overnight, there will be an over-the-air download. And this is for two reasons. One, to monitor progress of the app, because like I said before, we're working through these feature branches to make progress. And to demo new features. So, there's a demo day, let's say, every week. So, let's say it's, how many of you work with sprints? Raise your hands. Sprints? Okay, so sprints, it's just a way of partitioning the work. Think of it like that. You just come into an agreement with your team to say that, you know what, we will work every day on these features, but at the end of the week, we're going to cut and release. And that's it. It's the end of it's the end of this work. You just group work together. I'm just going to have a glass of water, please. Yes. So that's all. So you just come into an agreement to say, I finished the work for this week, and typically you would group it under some sort of feature highlight. Let's say in the bank, it might have been, okay, this week we work on the user login and all of the features that make up all of the stories that make up user login. So at the end of the sprint, we will have user login. So this, having the over-the-air download, helps you to do a demo at the end of the week and present the work that you just did. So that is why it's useful to show progress. And at the same time, once you're done, because you have over-the-air downloads every night, in case your product owner wants to check something, or your manager comes over and says, oh, can I see that feature you worked on yesterday? You always have a build ready. You don't have to go to extra to make a new build. You don't have to say, oh, ask Yanis. Yanis has the code. I don't have the code. It's always there. And every night you demo. And then eventually, after a week, you release, and you do a final demo as well for that release. And you mark that release by merging to master. Okay? So again, you indicate end of the work by merging to master. And at this point, another build triggers on Jenkins, now that we've merged to master, and says, okay, I'm going to do these things. I'm going to enable all the third-party libraries. I'm going to produce a test summary overall for your master branch, because now in simple words, now you've built your app with a release configuration. It's optimized, it's ready to go to client. It's no longer just for development. So you need a new test. And I'm going to run some integration tests and some security tests. Okay? So this is all happening. And I'll come back to what I mean by testing third-party libraries. I don't mean dependencies that you bring through Cocoa Pods or Carthage or some modules. So I'm talking about libraries that has to do with protecting your app from jailbreak, or obfuscating your code, or has to do with anti-tampering, so no one has messed with the code once it's out there. And these are things that you don't want them as part of your development. You don't need to have a third-party library during your development that checks against jailbreak or checks against obfuscates the code, because that will make your life difficult while developing. You run integration tests, so against the staging server, most likely. So at that point, when you release, you run integration tests to make sure nothing is broken. You run security tests against the device. And at that point, because I said this is the enterprise, you're not done. Because yes, you just merged to master, you just build your app with release settings, and you just run all these integration tests. But remember, you're not talking to the real thing. You're talking to something that pretends to be the real thing. And there's many environments that give you access to different data, different customer data, different configurations for all sorts of reasons. So at this point, what the pipeline will do is upon this being successful, it will take the same app, so the same app that was built from master, and build it to point and to work with a different environment. Okay? So the same app that we just built and we just tested it, it will just package it and point it to a different environment. One that had access to credit cards, another one that had access to loans, another one that had access to personal data. And there could be different configurations as well across environments. It could be that the SSL is different, for example. And pretty much that was the end of the pipeline. So to sum up, you start from your first two branches. As soon as you merge to development, that's when the pipeline kicked in. It would build your app, it would test. You would do that over a week. You would merge the master. It would run integration tests, it would run security tests, it would build it for release. That was successful. It would build it for all the environments. And then what happened after that? Basically, those different apps for different environments would be sent off to the QA team. So this is a team that is not a mobile team. They don't know about iOS necessarily. All they have is a phone in front of them, or 5 phones. An iPhone 5, an iPhone 6, an iPhone 10. And they were able to choose which version of the build they wanted and which environment they wanted to point to, and just install it on the device through the over-the-air download that I mentioned before. So all of a sudden, a QA team that had nothing to do with your team, through a single page, could choose the environment, could choose the build, could choose the settings for which to test an app. And you didn't have to do anything. This was all done as part of you working, as part of you merging the development, merging the master. And then there were things like on demand. So, yes, the QA team gave the thumbs up and said everything looks good. Then we had this thing called live proving in the bank. And this was the real deal. That meant you had access to everything. So the app, again, it wasn't done by an individual developer. This was all done by the pipeline. This was all automated. No one was nowhere near that. So you would just say, I want to build now for live proving. And what was live proving? Live proving was basically pre-production, let's call it. So you have the production environment, you have the pre-production environment. So still not the actual production environment, but pretty close. And at that point, once you did that, it was off to the QA team once again, and you wouldn't see it for a week, maybe 2 weeks, maybe 3 weeks. So you build the app, it was ready, you continue to do your work, and then someone else over here in the organization, being the QA team, would run all these tests more thoroughly against a production-like environment. So that's a bit of an overview. That was a long run, huh? Everyone with me? Everyone good? Everyone following? Let's talk a bit about the technical details. So how did all these things work and how did all these things come together? So, the main thing is that was a big pile of, not shit, scripts and ideas. But it was really like just scripts and ideas. How many of you have set up Jenkins? How many of you have worked with Jenkins? About a handful. For those that you know about Jenkins and have worked with Jenkins, you know that it's not a fancy tool. Especially if you're coming from iOS, you know, it's a bit clunky, it's a bit, you know, from the Java Enterprise days. And I can make this joke because I'm a Java Enterprise developer, and I have it. So, it looks like an admin tool. So it's hard to understand what is happening, and it's very archaic, let's say. It's very old in a single word. So it's hard to understand what's happening, and it's very basic. So a lot of the work that I just described was happening in a way behind the scenes. And it took a lot of time and effort. And this is something that I'll come back to. It wasn't done just like that, because it's not supported out of the box by Jenkins. The general idea behind this setup is that there is a script, just a script. It was a Bash script, but it could have been a Python script, it could have been a Ruby script, it could have been a Swift script, it could have been any script. But the basic idea is that there's a script that describes what happens on each stage of the process, of the pipeline. So what happens when we move to development? So that's the general idea. It's all based on the script. And you have to set up Jenkins. For those again that have worked with Jenkins, it's as simple as saying, you get a window that says, tell me what to do and how often. And you just put your script there. And then you would describe. So for example, for development, while merging development, we would say, you will use Xcode tools. So for those who don't know, how many of you know Xcode tools? Okay. So Xcode tools is just Xcode, but from the command line, you would see. You would say, clean this project on this kit, build it and test it. Simple as that. For the library, you would say, create this archive, and also create an IPA. And don't worry about the details, because there's a lot that you have to understand. So just focus on the high level. So you would just create an archive, and you would build an IPA, and that was it. Now comes the main, where the story deviates from Jenkins with environments. So as I said, we have environments. We have like a staging environment. And as I said before, environments were different, either in terms of the IP of the server that you were talking to, or an SSL certificate that you had to change because it was different than the other server. Basic things. Keeping it simple. And Jenkins was installed on a Mac Mini. Okay, so it was dedicated to do this work. And under the Jenkins home directory, there was a security directory called environments. And these environments had a list of environments per project. And what do I mean? Basically, under environments here, you have / the name of the project. Advantage, iOS, or TaxiBit, or Screws. And under this project, and each of those directories was actually a Git repo. And the reason why it was a Git repo is because you want to have consistency across your builds. So you wanted to make sure that whatever was there was the exact thing that you expected. So that using a Git repo sort of gave you consistency, to put it very in simple words right now. So all you would do is say, okay, give me all the directory listing under the Hello World project. Again, Git ls3 is just an ls. Okay? It just gives you a directory listing of, there's nothing fancy. So, and you would also pass the name of the branch. So in this case, master. And this will give you a list of environments. Okay? And then, as I said, you would clone that repo. So you would just say clone this branch, this environment from this project. And then this is what you would have. A development environment, a staging environment, and a production environment. Okay? These are just directories. Nothing fancy, just directories. And the script would basically just say, okay, I'm going to take these files that are in this directory and I'm going to copy them to replace the ones that I have. So if I had a server.plist in my iOS app pointing to a server on that IP, all of a sudden when I was building for staging, I was pointing to that. If I was building for production, I was pointing to that. So Jenkins, through this script that was running, would just say, okay, get this environment and just copy a file to replace that as part of building. Or replace this certificate. And through this way, you can have all these different ways to replace all these files. Maybe it was an image, maybe it was a logo. Maybe you were building a white label app and you wanted to change the logo. of the client or of the customer. The other thing that was really nice is that through this process of simply replacing the file and building against a project on an environment, you could use build settings, different build settings. And again, build settings, it's nothing different than what you have already in Extra. You typically have to mess with them when you set up some framework or some external library. It's that icon page that has all these settings that you see. On the left, you have that. The nice thing about build settings is that they can be defined in a file. So you can take them out of Xcode and have a single file that describes all those build settings. And by having this file now outside of your project and into your source, what does that mean? You can simply replace that file for an environment with different build settings. Just by replacing the file, just by doing the code. All of a sudden you have this dynamic build settings environment that you can turn things on and off. And you can set things like compiler flags. So for example, this thing means basically that I'm going to define a compiler flag called SSL ping. And by defining this flag in your build settings, that meant that through this config file, you could turn this thing on or off depending on the environment. How would you turn it on and off? By simply not declaring it. So if that thing was missing, it was on. If that definition was there, it was on. And then this SSL pinning flag, you could use it in your code, Swift or Objective-C, doesn't matter, and to say, if this thing is defined, then do that. So in this case, you could say, if SSL pinning is defined, execute this code. And remember, this is at build time. This is during compilation. Which means if that thing is not there, that means the code you wrote is not even there. And that is good practice. And I won't go into the details because there's too many things. But it's good practice because you no longer have code that is no longer used in your app. There's different reasons why you want to have that. But that would be runtime flags. And I won't go into that. And again, remember your script would simply say, build this, but then use this config. So there's a parameter saying build using this configuration. And again, as simple as that, you could have a different app. So again, these configurations, because having them in Jenkins, it would be hard to manage effectively. They were moved into their own Git repo, like the environments. So again, you would have a configurations repo listing all these different configurations, one for development, one for master, one for environments. And what this also allowed you is it allowed you to mirror the branches of your projects, say master, to the branches of the environment, to the branches of the configuration. What this means is, all of a sudden you could have your master branch building with that configuration in that way, while during that time, it's pointing to those environments. Or build version 1, which is a version we released a month ago, take the configuration from that branch, which is fixed and defined that time ago, against those environments that were valid that time ago. So all of a sudden you have this cross-cutting between your source code, your configurations, and your environments, which is everything at sync. The other thing is, the pipeline was using Jenkins agents. So again, I don't know how many of you have worked with Jenkins agents, but basically, you get distributed building for free. Basically, you can run Jenkins and then say, on a Mac Mini, and then say, okay, I have 2 other Mac Minis. Use them as your slave. And then you would have like, and I hate this word, you would have like a a Mac Mini which was like the host and two others working for the host. So that means if you were while you were developing your app and you had support from one Mac Mini, the other Mac Minis could be building for environments or could be building for every piece. So you weren't blocked, you have this distribution. And there's also this thing called tags. So within agents, you can say only use jobs that are tagged with this string. And this was useful, for example, if you wanted to support multiple Xcode installations. So for example, you were working on Xcode 9 and now Xcode 10 is around the corner, and you still want to have support for the other built with 9, fine. You would only have one Mac Mini with Xcode 9 and the other two with Xcode 10. And then you would, through these tags, you would just say, only build this up there and only build this up over there. And that was, again, that's all Jenkins. Didn't have to do anything for that. So effectively what's left of Jenkins really at the end? Jenkins is really just a scheduler. It's just a scheduler that schedules and distributes work. It doesn't really do anything. And it's all about selecting the correct configuration to use when you give it a project and a branch. So you say, I want to build abundance for version 1, and that's it. When I want to release the master. Or I want to support the master for this project every time I merge to development. And you get a distributed build system, as I said, that scales pretty good. So let's look at the details now. Why go through all this? Why build all this? Like, what did we get out of this other than the basic stuff about your code, compiling, and testing, and what support did it provide? So this was used by 3 teams across 3 different projects. Okay? All the automated builds and releases, basically, it would take something like 20 minutes to deliver across all environments. So 20 minutes from merging to master, and that was successful. In 20 minutes, you have builds across all environments. Well, previously, you would have to go to Xcode, change settings, make sure you put the right file, you put the right, archive it again next. 15 minutes to deliver to production. And obviously, you have all these quality gains, like making sure tests are broken, coverage is high. And we're automating unit and integration tests. That's per project, by the way. So for one project, we would have something like 2,000 tests that would run in 18 seconds. This is like tremendous business value. The ability to make a fix and know 20 seconds later that nothing is broken. It allows you to iterate very fast. We have 33 integration tests in 2 minutes. Again, that's talking to servers and making sure nothing is broken while we're building this thing. And as I said before, it's all about a feedback loop. And when you're a mobile dev team and you have a QA team that does your work, or does the work of the pipeline, then all of a sudden, not only feedback takes too long, because as I said before, at the time we went to production, it took the QA team 2 or 3 weeks before they would come back and tell us, oh, it's broken. And then we would have to fix it, and then it would take them 2 or 3 weeks again. So not only all of a sudden that feedback loop was shorter, but also our QA team, in a way, was brought closer to us because we took a lot of the work that they were doing and put it on this automated system. So the QA team had even less things to do and could only focus on the things that only a human could do and couldn't be automated. So not everything was great, and I'm wrapping up with this. There were some challenges. So first of all, consistency. So it was hard at times to keep the environments consistent. Now this didn't necessarily have anything to do with the pipeline and how it was implemented. Technically, it wasn't a limitation, but it's definitely something that you have to keep in mind of and you have to maintain. as your environments change, for whatever reason, certificates expire, you have to update the certificate, then the URL is no longer pointing to this, it's that IP address. You have to maintain all this. The other thing, which is even more important, is this idea of the burden of knowledge. And I think you should really read that, because I think it's important for every iOS developer, or everyone who works in a big organization, to know about this. But basically, the burden of knowledge talks about the idea of a single developer or a single person in an organization that knows too much. And by knowing too much, all of a sudden, you have this burden. It's like a chain on your leg that you carry around this knowledge, and everyone that comes to you and you cannot make a move without someone asking you about this, without someone coming to you to ask you something. And you just follow this thing around. So this pipeline, because I said at the beginning, I was the first one to come into this and start it all up. It was very hard for me then to distribute this knowledge. Because as I said, it was a lot of scripts and a lot of ideas that weren't necessarily modern. They weren't necessarily high level. They were hidden in scripts and in documentation. And the other thing was reproducing failures. And that's another big thing. How do you probably all ask this question, it works on my computer. It fails on Jenkins, I don't know why. It fails on the CI, it works fine on mine. It's this idea of trying to reproduce whatever has failed locally. And as I said, at the end of the day, this whole thing was just like a hack. It was a hack. It was a set of scripts, and it was obscure, and you couldn't understand how it was working unless you really built it. And Jenkins itself, as I said, it wasn't built for that kind of setup. It didn't know anything about environments, it didn't know anything about pipelines, even though since then, Blue 8 Ocean has been released from Jenkins, which introduces this idea of a pipeline, although I'm not sure I haven't used it since then. And again, we didn't have necessarily the full picture, like which settings were they used, what environments did it build for. Everything was working and it was automated, but you couldn't tell what was happening. In terms of future work, there is lots, as I've already hinted on some, by saying, how do you reproduce the local environment? How do you make this thing more visible? And there's a lot of things. I'll just give you a few highlights, like how do you automate performance testing? That would be a nice thing, to know that your performance has regressed, to know that all of a sudden you're no longer using 100 megabytes of memory, you're using 300 megabytes of memory. How do you make integration tests faster? And how do you spin up these environments with certain data in them? Because that was the other thing about environments. Data was different. So a lot of the times you would see failures that were failures due to the data, not necessarily because of the code. Because you were looking for a transaction and that transaction wasn't there, because the data wasn't there. Since then, there's been this post, which I think is quite nice to see. It's sort of like a modern take. It doesn't cover all of the things that I just described, but it's definitely worth a look. It talks about, this is from Pinterest, using Bill Kai. But it talks a lot about this idea of how do you reproduce environments locally, and how do you fix builds locally, and how do you have consistency. And that was me. Thank you. One more thing, let's say, if you allow me. So, obviously I built this thing 5 years ago, and I've left the job since then. For other reasons, not for this one. And then I went to the next job, and I was like, oh, do I really have to do this again now? And then I played with Xcode bots, and I said, okay, that's interesting, but again, Xcode bots felt kind of limited to me too. So then I said, like every developer that is true to himself, you know what? I'm going to build it myself. And I'm going to build a product out of it. So I built this thing called Windmill. And Windmill is, to give you some perspective, just to set the expectations, I've only been working on this full-time since January, probably, but I've been working part-time since, like my first commit is 2014, 4 years ago, yes, 2014. And eventually I said, you know what, I'm going to do this full-time. The thing I didn't say to you is that I've been living in the UK since 2010, and just this March I moved back to Greece. Now I'm saying I moved back to Greece, but I'm just here for now. Let's see. I don't know how long I'm going to stay. And since I moved here, and even before that, I've been working full-time on this thing, and I'm trying to do this thing. So I'm going to show you a short video clip that basically tells you, a lot of this will look familiar. It's only a minute, and then you can talk about me afterwards or whatever. That will be the end. I don't know if there's sound. Thank you. I don't know if we have time for any questions, or
yes, if there are
if people have any questions, or if I'll be here anyway afterwards. Everything clear?
Yeah. You said that understood already that you have two repositories, one for the source code and one for the configurations for the environments. What is the reason to separate by the
So the question is, what's your name?
Chris.
Chris. So Chris is asking, why were there two different repos, one for the source code over here, and one for all these configurations and environments? The simple answer, like the non-controversial answer, is that there is no real reason. You can have it in the repo. You know, there's different schools of thought, and I'm guessing this is where you're coming from, that whether you should keep all this configuration of how you build your project and how you test your project with your source code versus on a separate backend. But I'd say for now that this is a matter of preference, and I'm going to do that because it's a completely different school of thought.
Yes, I'm part joking, but how do you get 2,300 unit tests, assuming that there is UI in there?
Assuming there is?
There are UI tests as well.
No, there are UI tests.
I mean, exceed the UI tests, like just they hit the UI, right?
No, there were no UI tests.
No UI tests at all. Okay, that makes sense.
That's in the integration tests.
No. No, integration tests were simply,
Communication.
you can think of it as integration tests were basically testing your network layer, to put it simply. So whatever was on your network layer, the request, the parsing of the model, the response, that was an integration test. So this wouldn't be done from a UI, it would be done directly at the network layer.
Right.
And that's
What did you do with your UI, by the way?
That's a good question. So what did we do with UI testing? Again, that's that's a touchy subject. It's very controversial, I think. I have found anyway. Because I think it depends on your definition of UI test.
I mean, like rendering the table view, rendering the collection view, stuff like that.
Okay, so by UI test, you mean actually testing the visual aspect. You're not talking about end-to-end testing driven by UI. This is definitely, it was on the bullet points that I skipped through, this is definitely something to look into. There's tools, I'm not sure about iOS, but there's definitely tools for the web that you can basically automate taking two screenshots and comparing one with the next. And you can also have some fuzziness applied to it. So if a label just moves by a little, it wouldn't fail, for example.
Oh, but I'm saying, what do you do, like for instance, table view data source, elements and stuff like that?
So if you're talking about table view data sources, I think of this as a unit test. Because I wouldn't hit the UI, I would hit them all, the data source.
But you need to load the table, you need to render the table,
No,
How do you do it?
we'll talk about it later. Any other questions?
What tools that out of the Jenkins that you may use, I mean, TempCity or
That I have used, you mean, or
yeah, or you suggest for, I mean, now Fastlane is really cool, do a lot of things. TeamCity is really good, but you need to be really good at installing it and having it.
Yeah.
Other people may have to use to suggest.
So other tools, other ways to do this rather than Jenkins. So I've played with Jenkins, Xcode bots, and one more. Jenkins, Xcode bots. Oh, and Bodybuild. Was acquired by Apple. So Bodybuild was a cloud service. So I've used the cloud service, I've used the Apple's offering, Xcode bots, and Jenkins. Out of those three, nothing should it be. But maybe that's a personal experience, and obviously you saw that I went and said, I'm going to build something. Fastlane tools, it's very good. The main thing about Fastlane tools is, as it stands right now, it's not a scheduler. It doesn't monitor code. It's just a way to automate certain things, and it's great for that. I know they're building Fastlane CI, so that in theory I'm hoping could be a native offering rather than using Jenkins. But it's still early development, so I don't know how that looks or how it's going to evolve. Any other questions? Generally, or you can.
Also, Windmill is, can we have a beta of it or is it live?
Windmill?
Yeah.
Yeah, so Windmill is live.
Okay.
You can actually go to windmill.io and download it and play with it. I have it here if you want to see it before. I'm happy to show it to you. That's all. I'll be around so you can ask me.
Okay, we'll have a break outside.